we will use simulated data to perform the weighted least squares estimation in Stata. We will verify that the standard error for the WLS estimate could be smaller than the OLS estimate. Suppose the population model is y equals phi plus 2 times x plus mu. I set the error term mu with a zero mean and a standard deviation of x. In this way, the error variance equals squared x. The h function is x squared. According to what we just derived, the weight equals 1 divided by the square root of the h function. It is 1 divided by x in this case. With the weight in hand, we transform the outcome variable, the explanatory variables, and the error term in the original model. The error term in the transformed model has a constant variance that equals 1. In Stata, we begin by setting the number of observations. Next, we generate the explanatory variable, which follows a random uniform distribution. A key part of this setup is the error term. This error term is defined as a standard normal variable multiplied by the explanatory variable x. As a result, the variance of mu is equal to x squared. Next, we generate the outcome variable y based on the population equation. We can find the pattern of the heteroscedasticity when we scatter y against x. Now we have data that exhibit heteroscedasticity. We can compare the OLS and the WLS estimates. Both the WLS and the OLS estimates are very close to the population parameters we set. They are both consistent estimates. However, the WLS estimates have smaller variances or standard errors than the OLS estimates. For example, the standard error for the slope estimate is 0.017 in the weighted least squares estimation, but 0.024 in the ordinary least squares estimation.